Hey guys, this is ctrl+destroy. My name's Nathan, aka The One, and we're going to be continuing our series on the basics of getting started with OnBot Java. If you missed episode 1 where I went over basic Java programming, feel free to check that out. Otherwise, let's get started with setting up your actual OpModes. The first thing you need to know is that Java programming is split into multiple OpModes. So you will have one OpMode dedicated to declaring all of the parts of your robot. And then you'll have your tele-OpModes and your autonomous OpModes. So we're going to begin by setting up your robot's hardware. We're going to do this by making a new program called robot hardware. And it's not an OpMode. It will not show up on your phone as an OpMode you can click. And we'll be going off the template hardware pushbot. So it's called robot hardware. The sample we'll be using is the hardware pushbot template, and it is not an OpMode. We're going to press OK. So now here is the basics of how to set up your hardware. We'll be modifying this for your robot. It begins with a copyright in the form of a comment. We won't need this, but let me explain what a comment is. A comment is anything preceded by // Anything after the / is not executed. So you can say yes, or you can say this executes action. And this actually does not do anything. This you can read and understand something in your code or leave it for something like a copyright, but it actually does nothing for the actual code. So we'll get rid of that. We'll actually get rid of this comment here. And you'll see that it starts with what we went over earlier. It's the common first package, and it's porting stuff like what a DC motor is, what a servo is, what a hardware map is, and an elapsed time. So you can see it begins with the class. We are making the object robot hardware. And it begins with the public OpMode members. I'm actually going to change this to instantiate motors and servos. Here we're going to be making the motors and servos that are on your robot. So we'll get rid of this and start from scratch. First, you'll need to know what's the difference between a public and a private variable is. Public means it can be accessed from outside of this class. That means when we later call upon the robot hardware object in our OpModes, we'll be able to retrieve this variable. If we were to set it to private, only this class directly can use that object. So we actually want this to be a public variable. And it's going to be the type of a DC motor variable. And this is a unique variable. It's not something like an integer or a string or a boolean. It is actually a custom variable made by the hardware.dc motor we imported. So we're going to be making a public DC motor variable, and we'll call it motor1, and we'll stop there. We're not actually going to set a value to it. We're only instantiating it. We'll define it later down here. So we'll say that our robot currently has two motors, motor 1 and motor 2. We'll also make a servo variable, and we'll call this servo arm. Here are some constants that this program's making, but we won't use stuff like that. We will later use those in our OpModes. Now we will be creating the hardware map. A hardware map is just a variable that retrieves the configuration of your robot so you can access all of its servos and motors and sensors. We'll be calling it hardware map. We'll name it the same thing. So it's a variable of the type hardware map. It's called hardware map, and we will not define it yet. And this is creating an elapsed time, basically a timer, and we won't need that. And we also do not need this constructor. You'll see that we arose a lot of errors. This is because I did not delete this curly bracket right here. And now we are actually making the method that is in the class robot. So we're making a method called init. So that means we will later call upon this method in our OpMode, and we will use it to declare everything on our robot. And since we changed what the hardware map is called, we're going to change it right here. To clarify, this variable does not need to be named the same as this parameter. The variable is the actual object storing the configuration of your robot. The parameter just dictates what type of variable your method can receive and how it can be referenced within that method. This is the creation of a method. We are declaring a public method, a method that can be executed outside of this code. It is a void, which means it declares only actions, it does not output any information, and the method is called init. Init takes in one parameter. It takes in a parameter of the type hardware map, and it will reference it by calling it a hardware map. We don't need this right here as extraneous. Right here we'll actually be we'll define our motors and servos. So we have to define our motors and servos because right here we just instantiating them. We're making variables that will be used to reference our motors and servos, but these actually have no information attached to them. Now we will define them. So you do this by actually saying motor 1 is equal to hardware map dot get, and we're going to get the DC motor class as our first parameter, and our second parameter we'll just say motor 1. So this is saying of the hardware map that is given to us in this method, we are going to retrieve from that hardware map, we're going to retrieve the motor that is named motor 1. That means in your configuration you need a motor that is called motor 1, and it will attribute that motor to the variable motor 1. You could actually do something like motor left. This is because if you have your motor in your configuration of your robot on your phone defined as motor left, you can set that motor to be the motor 1 variable. It's just much simpler if you keep everything synonymous where motor 1 is equal to motor 1. We'll do the same thing. We'll say motor 2 equals hardware map.get is also a DC motor class, and in our configuration we will also call it motor 2. Also we will do our servo, so servo arm equals hardware map dot get, and this is actually going to be the servo class, and we will call it servo arm in our configuration. Next, we are going to set the initialization of all of our hardware. Because in our OpMode later, we'll be calling upon this in initialization, this is where you'll put what you want your motors and servos and sensors to do right when they start. So right here, we're going to set motor power. This is because right when we start the robot, we'll want to make sure that the motor power is set to 0. We don't want them moving. So we're going to do that for both of our motors. We're going to set their power to 0. Also, we're actually going to set their mode. And we do this by doing the code motor1 dot set mode, and we're going to do the parameters DC motor dot run mode, and we're actually going to use the mode run without encoder. This means we're not going to be using the encoder to run the motor. We are only going to be using power. Also, you can use the mode run mode dot run to position. This is for when in autonomous you want to use encoder positions to run your motor, and we'll be getting into that in a later tutorial. We'll do the same to motor 2. And right here, you need to make sure you're capitalizing everything correctly. If you capitalize something wrong, it will run an error and it won't know what you're talking about. Next, we'll be setting the motor's 0 power behavior. The 0 power behavior is basically when a motor is set to 0, what does it do? It defaults to float. Float means that if you set a motor's power to 0 and it's running at full speed at 1, it is going to slowly drift down to 0. Another a 0 power behavior is break, and that means it goes directly from 1 to 0 and it stops instantly. So we're going to do motor1.set 0 power behavior, and we're going to use the parameter DC motor dot 0 power behavior, and we're going to get the behavior of break. You can also set this to float. You could use 0 power behavior dot float. But for most use, break is going to be what you want, because you want your robot to stop exactly when you set it to 0. We are going to do the same code. We'll actually just copy and paste this. We want to set motor 2's power behavior to break, and then we're done with that. Next, we're going to do the servos. So we'll do set servo position. This is where you want your servo to start when it's initialized. So we'll do servo dot set position, and we'll just say that we want it at 0. This actually is not right because it's called servo arm, and there, the servo will start at position 0. We will remove this, and you're done. This is instantiating 3 variables, your motor 1, motor 2, servo arm. It's going to create a hardware map. It's going to create the method that uses a hardware map to define your motors based on your configuration. It will set the power, the mode, and 0 power behavior of your motors, and set the position. Now we are going to build this OpMode by hitting build everything. Sometimes it messes up, but build finished in 1 second. Build succeeded. This is because every Java program needs to be built. Built means it just runs through it, sees if anything will run an error, and then compiles it into something a computer can run. You'll see that if we do something like forget a semicolon here, it will run an error here, but also when we go to build it, it'll actually tell us exactly where the error is. On line 26 in column 27, it expected a semicolon. So, okay, place a semicolon there. Let's rebuild. We finished. So we've created a program that is going to tell us everything that is on our robot. As another thing, let me show you how you would add something like a sensor. So since we can't actually add a sensor right now because we don't have the information for it, we'll actually have to import a package. So we'll import, we'll use the same diction as the other ones, com.qualcomm.robotcore.hardware, and let's say we want a gyro sensor. I didn't just make this up. You would have to research what the exact diction of it, like if we tried to do just gyro sensor and we build this, this actually doesn't exist. There is no class gyro sensor. But gyro sensor will build, and we'll see it succeeded because the gyro sensor package actually exists. If you needed to add something that I'm not going to be going over, you would have to Google something like FTC gyro sensor Java and see what you would need to add to be able to define a gyro sensor. So here we'll say we are instantiate our sensors, and we'll make a sensor. It's a public sensor, and we'll call it our gyro sensor, or it's actually of the gyro sensor type, and we'll call it the gyro sensor. And then we will right here, we will define sensors, and gyro sensor be equal to our hardware map dot get. It'll be of the gyro sensor class, and in our configuration we will call it gyro sensor. Something specific to a gyro sensor is that you have to calibrate it, so we'll say we'll calibrate sensors right here, and we will have run gyro sensor dot calibrate. Now we're done. Your robot now has 2 motors, save for its wheels, a servo arm, and a gyro sensor. We built everything. Now let's get to actually using this hardware. We'll be making a file called driver controlled. And we'll start with the sample hardware pushbot tank iterative. And this is a teleapp. We'll start off by deleting that extraneous copyright. Also, we'll delete this comment right here. And we'll begin. You can skip over this imports. You already know what it means. Right here is the name of the OpMode and what group it's in. So then this is the name that will display on your phone when you go to choose it. So we want it to be called driver controlled. And also, we'll just stick it in the group teleapp. This will make an individual group under your programs, and we want them all in the same. So we want this in the teleapp group. This can actually be anything. Say you want to make all of your, this will be a test OpMode, and it'll go in the test OpMode group. We are creating the driver controlled object. It is of the type OpMode, and let's begin. So first, we want the first thing to run is calling upon our hardware. So we want to call upon our robot hardware object that we created, and we can call it robot, and we want to start a new robot hardware. We'll delete these comments here. We're actually going to make this say define robot. And now this is where we will put constants and variables that you want your entire program to access. So we won't make any now, but this is just where you'll put them. Here is code to run once when the driver hits init. We'll trim this down and say run once on init. And then you'll actually see we're going to call upon the robot object we have. Robot is just another word for robot hardware. We define that here. And in that class, we are going to call upon the init method, and we're going to use the hardware map we defined. Next, we're going to send a telemetry message. We'll just say, this right now says telemetry.add data, say hello, but we'll do something similar like earlier and say the status is initialized. So now when you press init, it'll initialize all of the hardware, and it will tell you that we are initialized after that. Right here, the init loop method is code that runs repeatedly after hitting init. So we'll hit run, we'll say loop on init. And we won't be using this. And right here is just code that runs once on play, actually on start. And here is the code that actually loops on start. So this is the code that is going to keep running once you hit start. It is going to be the main OpMode that you're going to be putting everything. Right here, they're defining two variables. Left and right, they're both doubles. And right here, they're defining them. They're making left equal to the left stick Y, and right equal to the right stick Y. Let's just trim that down and make it more exact. We'll say double. We'll say it is part of gamepad 1, so G1. This is to keep your two controllers variables separate. We'll say double G1 right stick Y, and this is equal to gamepad1 dot right underscore stick underscore Y. We're actually going to make this negative because the value is inverted. When you go up on the right stick, it's negative, down is positive. So we're going to apply a negative in front, so it inverts that for us. And then we'll make the other right stick, or the other stick, which is left. So we'll make it G1 left stick Y. That is equal to negative gamepad1 dot left stick Y. And that's good. Also, we'll do a button. We'll make a Boolean for our A button, so G1A, and we'll make that gamepad1.a. If you don't know the exact diction of how to call a button, we couldn't just say a button, because a button doesn't exist. It actually has to be called gamepad1.a. So if you don't know the exact diction for a button to call upon, you would have to research that. You can see that A is a Boolean. That means it's true or false, while G1 stick is a double. That's because the left and right stick is analog. That means it gives you a value from 0 to 1. On the other side, A is a digital button. That means once it's down, it is true, and while it's up, it's false. So just so you know, A, X, B, and Y are digital. The D-pad buttons are digital, and the bumpers are digital, while the sticks and the triggers are both analog. Next, we'll be using the same as what they do. We're going to be calling upon our robot, and we're going to call upon motor 1, and we're going to set its power to G1 left stick Y. We're going to do something similar here, robot.motor2, and we're going to set it to G1 right stick Y. So that means if you add a simple push bot, a left stick will be controlling motor 1, and right stick will be controlling motor 2. So the left and right side is your robot. Since motor 2 will probably be inverted from motor 1, you'd have to do something like negative G1 right stick Y. That means the negative value that you're getting from G1 right stick Y or the right stick. Here is just example code for a servo. We'll actually delete all of this. And we'll actually make an if statement here for our servo arm. An if statement is dictated by if and then parentheses. Inside the parentheses, we'll need something that is true or false. So we'll say if G1A, and that means if G1A is true. If we wanted this to be false, you could do if G1A is false. You can see we use two equal signs to mean if it equals. If we did one equal sign here, this will mean we're setting it to equals. We do not want to do that. You could also do if G1A equals true, but by default, if G1A is also automatically detects if it's true. And we'll do if G1A equals true. We want servo arm.set position, and we'll set it to 1. And we'll say else if G1A equals false, we'll say set servo arm back to the set position 0. We also can do this another way. So right here we're asking if G1A is true, do this, and if G1A equals false, do this. But actually we can do a simple if-else statement. That means if G1A is true, do this. Otherwise, set the servo arm position to 0. And since when G1A is not true, it is always false, this statement works the exact same way. And we'll just output some telemetry. We'll say telemetry.add data, and we'll say we want to know what our motor 1 power is. So we'll make the prefix motor 1 power, and we want to know what our robot.motor1.getPower is. So now we'll have on our phone displaying what the power of motor 1 is. To know all of the methods that you can use for, say, motors and servos, you can look on ftctricks.com. I'll link in the description, which gives all the information you need to know to program motors and servos. Now here is a method that runs once on stop. So run once on stop. And we won't actually do anything in there. You could do something in here like setting the servo arm back to 0 once you hit stop, but we won't do anything like that right now. So now you are done. You have defined all of your hardware, and you have made a program that runs your wheels and runs your arm. If you didn't understand something, leave a comment, or I'll address something in another video. But here are the bare bone basics. Later I'll be going into more complex programming. But for now, this has been ctrl+alt+destroy. My name's Nathan, aka The One, and I will see you in the next tutorial. See ya.